This video is about testing metal cations, and one way you can test them is using sodium hydroxide. So first off, let's make sure we really understand what we're doing in this section. So a metal is all of those on the periodic table, and a cation, well, an ion means it's got a charge, and a cation means it's got a positive charge. So you can detect these by adding sodium hydroxide. For example, you can detect magnesium ions, so magnesium 2+ ions, by adding sodium hydroxide. You can detect copper ions by adding sodium hydroxide. You can detect any of these, by adding sodium hydroxide. And the reason that they can tell you that they're there is because they form a precipitate. Now, a precipitate is something that's insoluble, so that means it can't dissolve. So when you mix, for example, this magnesium solution with sodium hydroxide, you'll create an insoluble solid that can't dissolve, so you can actually see it there. And quite often these have characteristic colours, which is what we'll get onto next. The next thing I want you to really understand is this idea of sodium hydroxide. So I'm going to show you on the next slide. So sodium hydroxide is made up of two parts. It's ionic. So you've got the metal part, the sodium, which is Na+, and the anion part, which is the hydroxide ion, which is OH-. Now, you can see you've got one positive and one negative, so together they can make that ionic compound. Now, what I want you to be really aware of is that it's the whole. So, if you've got the magnesium 2+, and it reacts with the hydroxide ion, the OH-, you form a precipitate. Again, all of these ions react with the hydroxide, the OH- ion, to form a precipitate. Now, the interesting thing about this is that the ionic compound must always be balanced in terms of its charges. So that means if this is 2+ here and this is a negative, well, it doesn't quite balance like that. And 2+ negative, all these are one negative. There's 3+, there's 2+, there's 3+, there's 2+. So let's try and balance some of these. Well, if I've got two positives, I also need two negatives. Therefore, I need two lots of that OH- anion. So I would have Mg, OH. Now that wouldn't be balanced because my Mg is 2+, my OH is a negative, so I've got too many positives. So I need to double all of the hydroxide, It's not this. It's not MgOH2 because I've still only got one oxygen and two hydrogens. I've got to double all of the hydroxide ion because it's the whole hydroxide ion that's a negative. So the next one would be copper hydroxide. The next one would be iron hydroxide. The next one, I've got three positives, so I need three negatives. So it would be that. Calcium hydroxide and aluminium hydroxide. So here you've used the brackets to double the entire, or in this case triple the entire hydroxide ion. So two of those, three of those, two of those, three of those. Now, all of these here are precipitates. So all of these are insoluble solids. So we'll have a look at these on the next page, and then we'll say what colour they go. So if you form magnesium hydroxide, well, that makes a white precipitate. If you form copper hydroxide, so this is copper 2 plus, that will form a blue precipitate. If you form iron 2 plus, this is 2 plus because I've got 2 hydroxides, that's 2 negatives. This forms a green precipitate. Iron 3 plus, so iron hydroxide but with 3 hydroxides, forms a brown precipitate. Calcium and aluminium both again form white precipitates. Now there is one difference to the white precipitates, and that is whilst the magnesium and the calcium make white precipitates, the aluminium, which makes a white precipitate, can dissolve in excess sodium hydroxide. So excess means you've added much more than needed. So actually the aluminium hydroxide white precipitate can dissolve. On the next slide we're going to do some equations for these reactions. So first thing to notice is you are going to form your metal hydroxide. So you will form your magnesium hydroxide, you will form your iron hydroxide, and you will form your iron hydroxide. Now, again, the reason it's OH2, because my OH altogether is a negative anion, my Mg is 2 plus, okay? This isn't quite done yet though, because any equation you've got to have, if you've got sodium on the left, you've got to have sodium on the right, so it's going to form sodium chloride. You'll also notice that this isn't balanced yet at all, because I've got 2 chlorines on this side, so go ahead, try balance it up please. So chlorines 2, chlorines 1, so I'm going to need big 2 here, big 2 here, and just check through. Yeah, that looks good to me. Next one. Notice you've only got Br2. Now bromine is in group 7, so it's only a 1 negative, but there's 2 of them. So that becomes 2 negatives. So this is iron 2 plus, which is why I've got iron with 2 negative hydroxides. I'm going to form sodium bromide. Again, I need to balance it, so big 2 there. Big 2 there, I'll have it balanced. Finally, I've got 3 chloride ions, so that's 3 negatives. So this is iron 3 plus, which is why I've got iron with 3 hydroxides. And my sodium chloride from here, is it balanced? No. So to balance it up, if I put a big 3 there, that'll give me 3 chlorines on both sides. If I put a big 3 there, it gives me 3 sodiums on both sides, and it will also match up my hydroxides. So they're all balanced.